Hey guys, today we're looking at permutations, which means basically ways you can arrange things differently. Now, let's do an actual one we can do with it ourselves without having to learn any formulas or whatever. We can probably do this here. Let's look, for example, how many ways can the letters A, B, and C be arranged in a row? Okay, so let's figure that out. Well, give me some ways you can, like let's say it's Arthur, Betty, and Charles. So Arthur, Betty, how many ways can we arrange these guys in seats? We can go Arthur first in the first seat, and then we can go Betty and Charles. Then we can go Arthur first and then Charles and Betty, right? What if we had Betty first? Then we could have Arthur and Charles, and we could also have Betty first and then Charles and Arthur. Or we could have Charles first and then Arthur and Betty, and then Charles first and then Betty and Arthur, and that's pretty much it, right? Okay, so you got three, kids. How many times can you arrange them in a row? Okay. At some point, people started messing with this stuff and figuring out what's the formula of this. How about A, B, C, and D? This is going to be a big pain. Okay. We can go A, B, C, and D. I'll tell you. Here's a trick that I'll show you. Okay. A, B, C, and D. We can go like this. All right. If A is the first letter, let's just do it that way. And let's just, how many times can we can go A, B, C, D, A, B, D, C, right? That's if the B is the second letter. How about if C is the second letter? A, C, B, D, and we could also go A, C, D, B, right? Okay, well, let's see here. What if D is the first letter? A, D, C, B, we could go A, D, B, C. So with A as the first letter, that is 6 ways you can arrange this. And of course, you could sit there and do all of these literally, just write them all down. But you could figure out, wait a minute, if with the letter A first, if there are 6 ways to do that, I bet the same thing would be true with the B, right? It'd be B, A, C, D, B, A, and you could go on and go, oh, there's 6 ways to do B with the first, let's say, chair or whatever. Or how about C is the same thing and D is the same thing, right? So if you have 4 numbers, there are 24 ways to arrange it. If you just have 3, there are 6 ways to arrange it. Now, what's the difference between 6? How would you go from 6 to go to 24? You multiply by 4, right? Well, that's interesting. That's the same number this is, multiplying by 4. And at some point, somebody went, wait a minute, I think I got it. 6, if you have 3 different numbers or letters or whatever, that's the same thing as, like, the first person, that'd be 3, let's see, and then that could be times 2, and then times 1. Wait a minute, I got it. That equals 6. And over here, you got 4 people, 4 possibilities for that first one, and then 3, and then 2, and then 1. And wait a minute, that's 24. Hey, let's try this again. Let's see if it works with 5. And then, of course, how many ways are there to arrange 5 people? Well, you probably figured out. It's not just 4 times 3 times 2 times 1, but what if there's an E? Well, then that gives you 5 times as many as that, which is going to give you 120 ways. In other words, if you have 3 persons sitting in chairs, there are 6 ways to arrange them. If you have 4 sitting in chairs, there are 24 ways to arrange them. If you have 5, there's 120 ways to arrange 5 kids in chairs. Crazy. Okay, and that's called, by the way, factorial. That's a rule. Okay, so that's what I just talked about. How many ways can 5 people arrange in a chair? This is called factorial. If you take the numbers 3 times 2 times 1, you would say this is 3. You call this 3 factorial. You don't go 3 like you're excited. It's just 3 factorial. This 24 is 4 factorial. When you write this, the people who look at this understand, oh, he means 3 times 2 times 1. Everything below that. The 4 means, 4 times 3 times 2 times 1, and 5, and so on. So how would you write how many ways 5 people can be arranged on chairs? You would just go, okay, that's 5 factorial. The person understands that's to mean 5 times 4 times, just beats, it saves a lot of time and space having to write out 5 times 4 times 3 times, all that kind of. Okay. All right, well, let's do another one. Ed bought his wife, Sue, 8 new dustpans for their 25th wedding anniversary. How many ways could Sue arrange the dustpans in a row before she attacked him with a curling iron? Okay, well, I guess that's a little domestic dispute there, but anyway. Okay, so how many ways can can Sue arrange these dustpans in a row? Well, If you had 2, it'd be 1 times 2. If you had 3, it'd be 1 times 2 times 3, and so on. The answer to this is 8 factorial, which means 8 times 7 times 6 times 5 times 4 times 3, and so on, times 1, whatever. Okay, well, this is 24. That's 720 right here. And then 720 times 56 is what you're looking at. So 72 times 56, let's see here, 432, and then 360, 2, 3, and then boop, and then the extra 0 there because I didn't put that one. 40,320. You wouldn't think that, like, you know, if you'd have 8 dustpans in a row, you'd think, maybe a couple of hundred ways you can do it. But I mean, 40,000 ways, this stuff gets out of hand really quickly. And if you had 9, you're going to multiply 40,000 by 9 all of a sudden. And then if there's 10, I mean, you're looking at the, I mean, it's just humongous number of ways. So anyway, we'll see this in a second. Here's another one. This, you need to make sure you understand this concept as well. This is a slightly different concept, but look at this problem. If Sue chose 3 dustpans at a time from her 8, and how many different orders could they be arranged in a row? Well, what we're going to do in that case is we're going to go, okay, well, out of the 8, there's 8 possibilities. And now there are only 7 possibilities. And now there are only 6 possibilities, okay? So we're going to multiply those 3 numbers. The top 3, 8, 7, and 6, that's what's going to happen. Okay, so 8 times 7 is 56, times 6 is 336 ways. That's how many times she can choose just 3 dustpans. Of course, that doesn't mean she just chooses from among 8, 7, and 6. I mean, she could choose 8, 1, and 2, 8, 5, and 7, 3, 8, and 2, or whatever. So that doesn't mean the dustpan number 8, dustpan number 7, dustpan number 6. This means for the first dustpan, she can choose between 1 through 8. So she might choose 1. From the second one, since she's already chosen 1, she might choose, I don't know, 4. You know, then from the third one, she might choose 7 or something. Well, that's one possibility. There are 336 possibilities of that time. So there we go. Okay. Look on page 389, practice problem A, give it a whirl, and pause it and try it. All right, and how many different orders can 9 objects be arranged in a row? Good googa mooga. This is gigantic. Okay, we're talking about, just a minute ago, we said 40,320 was 8 factorial. Isn't that what we said? 40,320? Okay. Well, that's going to be times 9. Okay, so 4,000, let's just do this. Oh, let's see. Oh, times 9, it should be down there. So 288, and then 36288, and then add the 0. Look at that. If you have 9 persons, let's say you have 9 kids in your homeschool co-op class. If the teacher says, okay, let's do all the ways we can rearrange you guys in order, it doesn't seem real that it's 362,000 ways you can arrange 9 people, but I'm here to tell you it is. Now, I don't know if you guys remember the Genesis where Joseph meets his brothers for the very first time after he's been in Egypt for like a decade or whatever. They don't recognize him. So, and he sits them down to eat. Okay, he sits them down and to eat with him, and they look around and they go like, "What in the world? Look at this! He arranged us all in age order." So they were shocked. Which, you know what? They should be shocked. You know what the odds are of arranging some 11 brothers in exact age order? I'm assuming that one of them, Benjamin was the youngest. It was probably pretty hard to tell who was older than who or whatever. But the odds of just getting 11 people in exact age order at random it's this. 11 factorial. Okay? That is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11. There you go. The odds of Joseph randomly getting these guys, of course he knew them, so he knew what their ages were. But the odds of doing that randomly were 1 in about 40 million. So no wonder they were surprised. Okay, anyway, all right. Let's do B. And how many different orders can 5 of the 9 objects be arranged in a row? Well, we're going to take 5 of those. The first possibility would be 9. Then we have times 8. Then we have times 7. Then we have times 6. Then we have times 5. That's 9 objects in a row. Now, the reason we ended up with the 5 is not because, oh, we have to use the word or the number 5. It just happened to be the last one. So this will be 9 times 8, 72 times 7 is 504 times 30, right? So 504 times 3 is 1512 and then a 0. So 15,000 ways you can arrange 5 things out of 9. That's crazy. Okay. All right, that is it for next time. 2 left. Do a good job on this problem set today. Really try to get 25, 27 right today, all right? Work on the ones you're having a problem with, okay? Do them right. All right, see you guys next time.